So, thanks everyone for coming. My colleagues, my friends, the members of the committee. Also, I think my family will be watching from Brazil, and my girlfriend from China. So, special thanks for all of you for coming. So the thesis is entitled Sectoral Patterns of Eco-Innovation, Theoretical Considerations and a Study Case in the Automotive Sector. I've been developing this thesis in the past 3 years with my supervisor, and my co-supervisor, Lars. I'll just discuss very briefly the outline of the presentation. The thesis is designed in 2 parts, one theoretical and conceptual considerations about the eco-innovation concept, and 2, a more sectoral eco-innovation patterns and empirical case in the automotive sector. But because I have only 45 minutes here and I have 5 papers to present, usually I struggle to present 1 paper in 15 minutes, so I'll focus on the second part, which is the core of the thesis, and I'll discuss very briefly the first part. Besides that, I'll make a small introduction and the overall conclusions. So, first of all, I'd like to start by saying that we are now in the 13th consecutive month of records in temperatures in the world. And scientists are pretty much sure that the human activities are at least partially causing this. So we need very urgently to understand how to change the economy towards more green, towards more sustainable patterns. And this thesis aims to contribute to this understanding by studying the dynamics of technological change, and because the technological change is fundamental to this process. So, the broad objective of the thesis is to understand these core elements, some of the core elements of the transition towards a green economy using eco-innovations, or innovations that are specifically targeted to reduce the environmental impacts of the human activities. The core of the thesis uses 2 classical evolutionary assumptions. First, that firms are core instruments of economic change and key actors in technological change. And second, that technological change presents very specific, sector-specific elements. So although these 2 assumptions have been broadly discussed for innovation in general, there's still a gap. There's still a gap in the discussion of these 2 assumptions in the context of eco-innovation. And that's exactly this gap, or part of this gap, that we want to discuss today. So the main research question, the broad research question of the thesis is, can we observe the rise of sector-specific patterns of eco-innovation in the automotive sector? So just a brief status of the papers. The first paper was a draft that I made for a course in Lund, and it's now submitted to the Global X conference. It's a conference paper, it's a potential conference paper. The second paper was published in the Journal of Cleaner Production in April. The third paper is also a conference paper presented at the R&D Management Conference. The fourth paper presented at Global X and now in review and resubmit in the Industry and Innovation Journal. And the fifth paper is presented at DRIT Conference 2014 and 16, less than 1 week ago, and also in R&R for Technological Forecasting Social Change. So in the process of doing the literature review for this thesis, I found some interesting conceptual discussion that originated the 2 first papers that I'll discuss very briefly here. So in the first paper, I discuss the boundaries of the concept of eco-innovation and the problems with the conceptualization of eco-innovation. So I argue that the concept of eco-innovation is very narrow, is very generalized, and doesn't capture the complexity of the eco-innovation phenomenon. Then I make a brief study case presenting one policy from European level that aims to define eco-innovation in the automotive sector. And I discuss how this policy can lead to very inefficient technological trajectories, green technological trajectories. In the second paper, it originated from a discussion, informal discussion with two of my colleagues, Simone and Roman, and we developed this discussion in a paper. And the discussion is basically, are there any difference in terms of meaning and scientific communities in some of the main terms that we relate with sustainability and innovation? So we investigate 4 terms: eco-innovation, environmental innovation, green innovation, and sustainable innovation. And we do a bibliometric analysis and run some statistical analysis to check if these 4 terms if they represent the same meaning, the same communities, scientific communities, or if they belong to different communities. And we find, contrary to the literature, that indeed they belong somehow to different scientific communities and they share different meanings. So now I'll focus on the main part of the thesis, the core of the thesis, where I investigate the formation and the existence of sectoral eco-innovation patterns in the automotive sector. In this paper, I have 3. In this part, I have 3 papers, sorry. They were all developed with my supervisor, Mai. And the first one, we developed the conceptualization of what we mean by sectoral patterns of eco-innovation. And the 2 last ones, we applied that to the automotive sector. So first of all, we, as I said, posit that as for general innovations, it's possible to identify sectoral eco-innovation patterns. And then we discuss why we think that this is possible. First of all, the boundaries of a sector are delimited by the products and the activities that firms do. And some of the environmental impacts are specific to these technologies, specific to these activities. So, for instance, and this affects how different sectors deal with these environmental impacts. So, in terms, for instance, of visibility of the environmental impacts, in the cement industry, the environmental impacts are huge, but they are very specific to one productive process. In the plastic industry, the main environmental impacts undergo after the use of the products. When, for instance, the plastic goes to the sea, goes to the Pacific Ocean. So, and also, of course, in the cars, in other sectors, we have different visibility for this, for the environmental impacts. The scandals are very much specific to technologies as well. Some scandals in the oil sector, oil exploration. We had now recently the scandal in the Volkswagen, in the automotive sector as well. And also the gap between the impacts of the dirty technologies and the green technologies varies in the sectors. And related to that, we have the existence of vertical environmental policies. So policies that are specific to some sectors. Because We have, for instance, policies that are specific to the automotive sector, environmental policies that are specific to the oil sector, and so on. And in each sector, these policies vary in strength and in scope. So, for instance, in the oil sector, the power of lobby is very strong. That affects how the policies are formulated, the impact of these environmental policies. And that, of course, affects the technological change, the green technological change in this sector. In relation to the demand, we also have that some characteristics of the demand are sector-specific. So, for instance, the elements like consumer routines are specific to products. So when we change from one dirty technology to one more greener technology, we somehow may affect the routines of the consumers in different ways for different sectors. Also in terms of the price elasticity of demand, we have changes when we change from a dirty to a green product in different sectors. We have different elasticities of demand. So let's say both in terms of routines and in terms of prices, if I say that a consumer, if I put two cases, one in the food sector, a consumer that changed from a normal tomato to an organic tomato, and in the automotive sector, a consumer that changes from a normal car to electric car. So it's much easier for a consumer to change from a non-organic to organic to then, for instance, to change from one normal car to the electric car, because there are different routines involved, there are different price elasticities involved, and all of that is somehow sector-specific as well. And the last one is the industrial characteristics, and that very much overlaps with the traditional innovation. That is that the competitive and organizational structures, they affect the technological change. And we argue that this has a different effect if we analyze the traditional innovation and the green innovation. Why? Because some of these green technologies are more radical, they require a lot of institutional change in the firms, they require a lot of resources from the firms, and sometimes the competitive structures are so focused on the core competencies that the firms don't have much room to change, to develop different technologies, more radical green technologies. So, if we consider the greening of the economy as a learning curve, in which we have the integration of these environmental issues in the economic processes, the heuristics of the firms and the agents in the economy, then we have different phases that are related with the development of the green markets. So the first is the reactive phase, when firms react to external conditions, like new regulations or demands from the society, or changes in organizational structures, and then they start to incorporate these environmental issues. And then they start to begin this green market development. But if we decompose the overall greening of the economy in different sectors, we see that these phases, they occur in different timing for different sectors. Because the development of green markets is somehow also dependent on these sectoral specific characteristics that I discussed before. So in some of these sectors, it may well be that the firms start earlier to integrate these environmental issues. And in other sectors, they start later than the average of the economy. If we decompose even further to the sector level, we see that in different sectors, also the firms, they go green, they start to integrate these environmental issues in different timings within the same sector. So it may well be that in one sector, we see all the firms converging to this average of the sector because they all perceive similar opportunities, because they all perceive similar risks. And in some other sectors, we see firms that are divergent because they see different conditions. Maybe because the sector-specific patterns are not so strong. Maybe because other conditions, country-specific conditions or firm-specific conditions, like firms that adopt very specific environmental policies, environmental internal policies, they may start to incorporate this earlier than others. But how can we really measure the integration of these environmental issues in the processes of these firms and of the sectors? So how can we really see this with the data we have today available for analysis? So I argue that the firms, of course, have limited resources to invest to develop different technologies. So they have the certain amount of money, resources, human capital to do their research and development processes, and they can allocate that in different technologies. They can make research projects to develop different technologies. And of course, some of these technologies will be more green than others, somehow. We are not sure of how to measure this impact, but we can say that some have apparently they are more green than others, for sure. So if over time we see that they are allocating more money to the greener technologies, to the more green technologies, then we can say that somehow they are incorporating these environmental issues in the heuristics, in what they use to develop new technologies. They are deciding to develop more green technologies. Okay, but this can happen because many things. It can be because in a certain country we have specific regulations, then they decide to change this, to allocate more resources to green technologies. It may be because, as I said, in a certain firms, they decide internally to go green, not specifically, not broadly speaking the sector, but maybe one firm starts to develop the green market by itself. But if we start to see the same pattern in other firms from the same sector, and we extrapolate that to most firms in a sector, then we say that this convergence is affected by sector-specific elements. Then we can say that it's not only one firm that is going more green. All firms in a sector are going green as well, or most firms. And this is a strong indicator that in this sector we have some sector-specific patterns driving the greening of the firms. So how can we see this process in the firms of allocating more resources to more green technologies? And in our view, we can see that by looking at the technological strategies of the firms that are reflected in the patent portfolios of the firms. So if we can, in the patent portfolios, recognize which technologies are more green, and we see over time that firms are developing more green technologies in the overall portfolios that they have, so we can say something about this process here, Of course, we know that patents have many flaws. The patent data has many flaws. It's an indicator of invention. It's not all inventions are patented, but it reflects somehow the knowledge, the production of knowledge in the firms. So we use the patent portfolio analysis as an indicator of maturity and to indicate the technological competences and the knowledge stock of the firms. So if we see more patents in this, what we call here green patents, if we see more that in the portfolios of the firms, they are developing increasingly more green patents, we can say something about this incorporation of environmental issues. So we use the automotive case as study because, first of all, it's a sector where we have different technologies in different levels of greenness, and because we also have, it's a mature sector with many pressures to change, so we can see this process ongoing. Firms in the automotive sector patent a lot. There are big firms. They have lots of patents. So we select 18 car. Oh, and just to say here, the ideal case would be to compare sectors, of course. But then I had 3 years to make this PhD, and I made 2 papers only with the automotive sector. So I would say that this is an ongoing research for me. I'm just in the beginning of this. I have to compare different sectors. Of course, I agree. But here I have 2 papers, only 3 papers on that. So at some point I have to stop and do start something else. So I selected 18 manufacturers, generating 140,000 patents. But then how can we recognize which patents are these green patents? If you get the patent, if you look at a patent document, you see that they have these codes, the examiners of the patent, they attribute a code to the patent. And this code indicates which technological field this patent belongs. Sometimes we have one code, but there are, of course, very often to see patents that have more than one code as well. And for instance, this one is related with electric vehicles. If we go to the classification, is arrangement of mounting of electrical propulsion units for vehicles. So it's basically electric vehicles. And we have lists. I used 2 lists of these codes that are related with green patents in different sectors. So I chose the ones that are related with green patents in the automotive sector. And which technologies I use? I recognized a group of patents related with internal combustion engines, which are basically the dominant design today for the sector. Hybrid and electric technologies, fuel cells, and also a group of complex patents. Because, as I said, sometimes we find patents that have 1 or 2 or more codes related to them. And sometimes we have patents that have codes related with this group and codes related with this group, or this group and this group, or this group with this group. So all these patents are, we call them complex because they represent this cross-fertilization between the technologies. So the objective of the 4th paper, which is the first empirical paper of this session, is to map and analyze the dynamics of green technology development in the automotive sector for the past decades. So it's more focused on the aggregated picture of the sector. So we ask, has the greening of the sector been based on the dominant design or also on the other alternative technologies? is there convergence or divergence between the strategies of the firms? And what's the impact of the main policies in the greening of the sector? We use basically two indexes. The Herfindahl-Hirschman index is a concentration index, and the specialization, the relative technology specialization index, which is a measure of how specialized are each firm in each technology compared with the other firms in the sample. So we have, in the denominator, we have the share of the technology, one of those technologies, in the firm, and the denominator is the average of the share of this technology in the whole sample. And then this picture just shows the evolution of the green patenting in this sector. And what we see is that overall, the total green patenting in the sector has been increased almost in a linear growth. At the first years, the first decades of green patenting, it was basically related with the ICE, the internal combustion engines, which are very closely related with the dominant design. But then, after some time, we start to see this gap between the development of ICE and the development and the total patenting. And this gap here relates with the other technologies, the electric hybrid, the fuel cells, and also the complex patents. So I just put some milestones here. The first pollution regulations here, in the United States, in Japan, Europe. The Brundtland report, Our Common Future. The CARB review, some regulations related with emissions in the United States. Here at the C, I put the first review of some of the zero-emission vehicles regulation, the failure of the GM program, the Kyoto Protocol, and very importantly, the introduction of the Toyota Prius, which was the first mass-market hybrid vehicle to be commercialized. So what we see is that maybe some of this, the growing the gap here is very much related with what happened in the 90s. Here is we see that there was impressive growth in the 90s in terms of the total green patenting, but it's still very much influenced by the internal combustion engines. And after that, we see the internal combustion engines more or less decreasing, the very slow rate, and the other patents increasing. When we analyze the Herfindahl index, we see that there was a dramatic reduction in the concentration of the patents. So this indicates that more firms were developing this technology. More firms started to develop these technologies, so it reflected in the patent portfolios. And so that made the Herfindahl index decrease. It decreased in the very beginning for the ICE and the electric hybrid, and then it took more time to decrease for the fuel cells. Still, fuel cells is a bit higher than the others. And again, dramatic changes after the 90s here, after the policies here. When we look for the technological specialization index, we see that the individual portfolios in the overall, when we see the big picture of the sector, they were converging to zero. And yeah, that's important. I normalized the index. So the index, this specialization index goes from -1 to 1. From -1 to 0, that indicates, of course, if you see here, I just put the picture here. If it's from -1 to 0, it means that the average of the share of this technology in the sample is higher than the share in this firm. So the firm is less specialized than the average. If this index is 0, it means that the share of the technology in the firm is more or less the same as the share in the average of the sample. And if it's from 0 to 1, means that the share of this technology is higher in the firm than in the average of the sector. So the firm is more specialized in that technology than the sector. When we check the individual portfolios of the firms, they're all converging. So it's going from -1 to 0. So that indicates that all firms are moving to this point where the share of the technology in their portfolios is more or less the same as the share in the sample. And that is an indicator of convergence. And we also see that this is becoming more stable, which means that there's not much variation in these strategies. They are converging to 0, and they are also becoming more stable. They are stopping at that area of convergence. But for fuel cells, we see that this convergence is not happening at the same intensity as the other technologies. So what we got from here is that maybe there are some firms, there's a gap that is higher for fuel cells. So there are probably some firms that are less developed, less specialized, and some firms that are much more specialized. So, paper 4. The main contribution is we first see the convergence in the technological strategies for all the alternative powertrains considered, all the technologies considered, which we see as I explained, a sign of this collective perception of risks and opportunities in the firms in the sector. This increase in the patenting activity challenges some authors that say that the attempts of going green remain marginal to the sector. It may be marginal in terms of the market itself, but firms are really trying to develop the new technologies. This represents now almost 30, 40, 35% of all the technologies that these firms are developing. So that's a lot that they're investing to change. We see somehow, although we don't do statistical analysis here, we see the effects of the regulations implemented in the 90s. For instance, for example, the California Air Board regulations, Clean Air Act, the first European standards, that in fact somehow they affected this, or at least the timing is of these two events is very close. And some authors discuss the existence of hype cycles, which are cycles it has to do with the expectations of the agents. They go into cycles of excitement and delusion about the technology development. So we would expect to see something like this here, the development of one technology going up and then at some point slowing down again, and some other technologies going up and slowing down. And what we see is quite the opposite. They are all more or less cumulative. We could say that this effect here in the fuel cells might be related to that, but the effect is not as strong as some authors claim. Okay, so the last point. We saw that the convergence in fuel cells was less intense. And then I was asking, why is this happening with fuel cells? What is special about these technologies? And then I decided to go further in the data to the paper 5. And then I analyzed the firm level, how the firms, not the sector, but how the firms are changing their technological strategies. So the objective of the paper 5 is to expand this analysis that I conducted in paper 4, focusing on the firm level and combining with other sources of data to say something about what's wrong or what's different with the fuel cells, the group of fuel cells. So we ask to which degree the individual automakers change their technological strategies, the degree of heterogeneity, and how the firms have been positioning themselves in the fuel cell technology. So this time, I used the Relative Technological Specialization Index but I plot the data in a graph. I plot the mean of the index and the deviation from the mean. And what I want to see is how each individual firm moves over time in relation to their specialization. So I have, again, the same I divide by 4 phases that are related to those milestones I showed you before. So each dot will represent one firm in one of these 4 periods of time here. So if we expect, if the firms move like this one from the first blue period, going to more specialization in this technology, but with more variation, so it's going up and down in the specialization, and then it moves to a more stable average here. So that is an indicator that the firm is converging. So when we go to the data, I know that this is a bit messy, but the important thing is the overall picture. What we see is that in the first periods, they were pretty much unstable trajectories, less specialized, and they converge to this stable mean, the stable area in the last periods of time. So in the last phases here, phase CD and phase DE. For the ICE technology, for electric hybrid, we can see that very clearly, they converging to the average. To the complex patents as well, even though it's a bit more spread, we have some firms here. But for fuel cells, we have 2 divergent trajectories. We have some firms that are not specialized at all in fuel cells, and we have some firms that are very specialized, or somehow specialized. So I also plotted the data. I used the cluster analysis data to see how the variation in the firm's strategies changed over time. And this dissimilarity measure, it's basically an Euclidean distance between the variation of the firms, the Relative Technological Specialization Index. And the more dissimilarity we have before the groups merge, the more different are the groups. So we can say that the groups, the trajectory of variation of this index, specialization index, in the ICE is very similar. Electric hybrid, a bit more different, but still very similar. Complex, a bit more different, but still quite similar. And then fuel cells, we have very distinct groups, which are exactly these 2 groups here. So if we divide, and of course one group of the leaders, one group of the laggards. If we divide these 2 here, if we split the 2 main groups in each technology, and we analyze the values of the specialization index, we see that, of course, they were decreasing over time, indicating that they were converging for electric hybrid, ICE, complex patents. They were all, the difference between the two main groups, two main clusters, was decreasing over time. This is a special case because the main groups of ICE, we have only three firms here, so these are the very big leaders. So just disconsider this, but for fuel cells, we have a big difference between the groups. And this difference is not decreasing over time. It's actually pretty much stable. It's decreasing a bit, but still pretty much stable. So from that, we see that the firms, again, if we look at the firms, we also see this convergence in the strategies for ICE, hybrid, and complex technologies. However, there are two very different divergent groups for fuel cells. So we want also to investigate which other characteristics are associated with the decision of being specialized or not in fuel cells. So which characteristics of the firms that are correlated with the decision of being in this cluster or being in this cluster. So we construct a panel data analysis using some of the years, especially the last years, where this convergence really occurs, to test the correlation between some of these characteristics and the specialization of the firms. We estimate a random effects linear model, and we want to see if the decision of being specialized in the patents, in the fuel cells patents, is related with profit margins that represent the performance of the firms, the R&D intensity of the firms, which represent their innovative capacity, the stock of patents, representing the knowledge stock of the firm, sales, representing the size of the firms, two dummy variables to represent country specific, so the country of origin of the firms, and one to represent the financial crisis. This is a dummy variable as well to represent what happened if the financial crisis and all its consequences have any effect on this decision of specializing. And what we see is that basically profit margins have a positive and a relevant statistical valid relationship with the decision of investing in fuel cells. Also, the knowledge stock is correlated with this decision. The financial crisis has a weak but statistical relevant for the last model as well. And also the decision of, sorry, I forgot to explain this, but these are controls that I put, the average number of inventors and assignees to represent the collaboration patterns and the decision of specializing in the other technologies. So it's quickly associated as well with the decision of investing in electric vehicles, which makes sense because both are technologies that are a bit far away from the dominant design. So the results, first of all, corroborate the findings in the paper 4. There's convergence independently of the firm home country, because this was not relevant here, at least in the model. But this convergence has also technology-specific elements, because we see that for some technologies, this convergence is also different. And we also see some firm-specific elements in this analysis. So the development of fuel cells is considered more complex and risky in the literature. And so we see that only the automakers that present better performance, better internal resources, would have enough incentives, or would perceive better opportunities of investing in these more radical technologies. No country-specific characteristics are significant. That might be because this is a global industry. So even very specialized, very regional regulations like the ZEV, the zero-emission vehicle that is specific to California, may affect the whole, all the firms in the sector. And finally, we stress that for policymakers, they need to create conditions to maintain the firm's performance, especially to invest in more radical technologies. So I'll just discuss very briefly the main contributions of the thesis. Now, how much time I have?
About 5 minutes.
Okay, perfect. So, first of all, I discussed and I analyzed the concept of eco-innovation in 2 different dimensions. First, the concept itself, and also the different terms that are related with this activity that we call eco-innovation. I think we need to develop better concepts of eco-innovation, first of all, that could represent the complexity of this phenomenon. The thesis, I think the main point and what I like in the thesis is that I could articulate different dimensions. So the firm level, the firm strategies, and also relate that to the technologies, and also relate that to the sector. So we know that the evolutionary theory is strong because of the micro foundations. And here in this thesis, I tried to really go to the micro foundations of what we call the sectoral patterns and try to see how these sectoral patterns are formed over time, how the evolution of the technological change may develop this convergence in the firm's strategy. The results indicate the existence of this convergence for the automotive sector, reflecting, as we discussed, the emergence of the sectoral patterns, the emergence of collectively perceived opportunities and risks on the firms, and as suggestions for future research, as I said, more accurate definitions of eco-innovation, but also to expand this empirical analysis to other sectors. That is really important, both to validate the results here, but also to expand our comprehension about the differences in this convergence in different sectors. That's it. Thank you.